So I wanted to quickly show my thinking on this pulley here. Um, Essentially, I only have a 10 millimeter length by quarter-inch D shaft, and I think if I were to try to connect that with plastic and grub screws, there's so much torque that's going to be delivered here, it wouldn't last more than a minute or two. So what I've done here is I've just kind of mocked up the ball screw. It's like a 14 millimeter ball screw, and then you've got this little D shaft on the end. Go ahead and hide that real quick. Um, the the main component of this is this 2-degree taper with a flat. So I put the flat on here to make sure that any torque that gets delivered isn't gonna, I'm not worried about the friction of the taper to deliver the torque. The flat should deliver the torque. The taper should hold it in place, and hopefully the flat delivers the torque. Now I thought about making the flat parallel with the taper, but it's only 1 millimeter, and the small end of the diameter is not small enough to taper it all the way down to 1 millimeter. So I'd have to actually make the entire the other part of the body smaller in order to do that, and that didn't work out. Um, so so this is what I ended up with. So I've printed out one of these, and to add a little bit of insurance, I'm going to epoxy it together. For the smaller pulley, I'm going for a 4-to-1 ratio. So this is an 80 tooth pulley. I'm going to use a 300 millimeter belt, and then I'm going to use a regular old straight, no taper, and with a press fit. And I've ordered these 20 tooth pulleys in aluminum from China. But they're going to take anywhere from 2 weeks to a month and a half to get here. So I'm going to make these temporarily, and the hope is that I can use this in a more permanent way. The interface to this, I should be able to, if there's teeth wear or I start to get any problems with the integrity of this printed part, I can always press the core right out and then go ahead and press it into another print, and maybe I add more infill, or I change the wall thickness. There's a lot of different things that I can do to beef this up if I need to. So right now I'm going for lightweight, but it may be better to go for more structural integrity. I don't know how much load's going to end up going on this. So that's the design, and that's that's what I'm trying to test out here. I haven't seen anybody do this on a CNC conversion, so. Hopefully it works out, and somebody else can leverage this flat and the taper to kind of help deliver the torque.
So here's my setup. I've got this part that I made. It's got a 2-degree taper on it, and then this part will mate to these set screws will mate to the 3/4 inch screw on the KR33. That's such a good sound. Maybe I should have put more infill. That is not what I wanted it to sound like. Oh, tolerances are tricky, aren't they? Alright. This won't be a perfect test because the other shaft has a D. It's a D shaft. Well, actually that doesn't look that bad. Okay, here's the new belt. I've done a quick calibration. This is 1mm steps. Whoops, not like that. Well, I might as well show that because it's so nice and level. Isn't that nice? Anyway, I don't know if I should go up or down. I think I should go down. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think that there's probably some imperfections in the print. Some of those should wear in. All right, I'll go up in 5mm increments. So it's decent. It's not perfect for sure. But I'd say that's not too bad for something that's printed. And I just crashed into the sensor. Well, at least my limit switches are working. So this is the assembly here. So they're both Presnel, and this one's super glued to the aluminum part, and then this one here, I did some epoxy. And it was a much tighter press, obviously. I think I'll put that video in because it was such a horrifying sound. So the next thing I'm going to do is I'm going to run the math on the optimal pulley centers, and then I'm going to make a plate. Obviously I had to put a little shim in here to test it, so that my heights have changed a little bit because this belt is 15mm and that GT belt is only 6mm. So I'm going to make the plate the right thickness. You can see here, this isn't even an 1/8 inch thick, and it's steel, which is great. But I've noticed that the motor will oscillate a little bit like this, and then you can also see this flexing down and up. So what I'm going to do is I'm going to use these existing mounting holes, and they're into this. Whoa. They go into this very beefy steel part that actually holds the retainer nut for the ball screw. So I'm going to utilize those with a thicker plate, and I think this is about, I'm going to guess it's about 10 to 12mm. So with a 12mm plate, even though it's aluminum, once I anchor the whole thing down to here, that'll work. But in order to do that, I have to have a clearance hole big enough to slip over this thing right here. So, and also clear the square nut on the ball screw here. So I think this temporary setup works well enough because it's kind of constrained back here with this screw. Maybe it's not that solid. I don't know. I really don't want this thing to crash, so maybe I need to get another clamp on there before I do any more testing. But I'm hopeful I can get it solid enough that I can machine this part on this mill. So yeah, I think this worked out. It really remains to be seen how well it wears. I mean, generally in what I've noticed is the plastic doesn't wear a whole lot in a pulley application, and the plastic does pretty well because this is a compression load, and because of the way it's printed, it's kind of an optimal strength situation for 3D printing. And then the fact that I have an aluminum tapered core with a flat on it, that should take out all the backlash from the connection. It was my biggest concern. Now there's only a 1/4 inch by 10 millimeter nub that sticks up here from the ball screw, and that's probably the weakest link in the whole thing right now.